Hello, I'm Dr. Gray. I'm going to be walking through your first experiment, page by page, and tell you how to do everything. So our first experiment is exploring density and glassware. What we're doing is we're utilizing what we know to be the density of water, 1 gram per milliliter, which is detailed in this purpose right here. So what we're going to be using that for is to compare a total of 4 different pieces of glassware. So in your lab, you're going to have 2 different faucets. This is a lab that we're not using, but you can see right here, there's 2 different faucets. This faucet right here puts deionized water out. This faucet right here has, well, regular tap water. If you notice, the tap water has hot and cold settings, whereas the deionized water just has one setting of, well, let the water flow. Okay, now on the second page of your procedure, introduces you to a digital balance. Now the digital balance that your lab is equipped with is one that looks like this. This one right here is by a manufacturer known as BWR, and what this piece of equipment will do will determine the mass, or will measure the mass of something to 2 decimal positions, or 2 positions beyond the 0. So that will measure to the 100th position. It will not measure to the 1000th position. This piece of equipment is not that precise and is not accurate up to that point. Now, what this shows is if you have something that has a mass of 1.00 grams, that means that that number has 3 significant digits. It does not have 4. A 4th significant digit would be 1.000, a third 0 after the decimal place, but this instrument has a limitation. Are there instruments that are more precise than this instrument? Absolutely there are, and that's compared and contrasted in your lab manual with what's known as an analytical balance. Okay, at the bottom of your second page, there are some measurements or some readings that show you different masses. 0.08, 8.00, and 0.80. What you're asked to do is to label simply the number of significant figures in each one of those numbers. Page number 3 introduces you to significant figure math. So when you have numbers that you've collected from a digital balance like this, how do you use them? And the rules for significant digit math when it comes to addition and subtraction are different from those whenever you're dealing with multiplication and division. When you're talking about addition and subtraction, you are going to round your numbers to the fewest decimal places. When you're talking about multiplication and division, you're going to use the fewest number of significant digits from the numbers used in the calculation for your answer. So I have a total of 4 different answer options, or 4 different numbers there. So I have 34.325. That number has a total of 5 significant figures, or significant digits. 34.325 minus 1.26893. Now, if you plug that into your calculator, you'll likely get something like what is displayed here of 33.05607. But this is an example of a subtraction problem with numbers that have different number of significant figures. And so what's your goal? Your goal is to use that calculation and then come up with an answer and round to the fewest significant digits, or the fewest decimal places, fewest decimal places. So an answer like 33.05607 should be rounded to 33.056 because the number that follows that 6 was a 0, so you can't use that to round up or round down. Now, I'm going to jump ahead to a multiplication question. 13.9 times 3279. So 13.9 has 3 significant digits. 3279, or 3279, has 4 significant digits. The rule when it comes to multiplication and division is you're going to round to a number that has the fewest number of significant digits. So we had a number with 3 significant digits and then a number with 4 significant digits. Our answer is going to be rounded to only 3 significant digits. Now, if you plug this into your calculator, your answer would be something like 45578.1. The way that you round a number like that to only 3 significant digits is you use something known as scientific notation. And you'll see that displayed as times 10 to some power. Now, our number was 45,578.1. We're going to round that to only 3 significant digits. So we're going to take the first 3 numbers, 455, and we're going to round that to 456 because the number that followed our second 5 was a 7. So we're going to say 456, and we're going to make that 4.56 times 10 to the 4th. Now that's a positive 4th. You might be looking at that number and thinking, well, why is it a positive 4? Because if you convert that number, 4.56 times 10 to the 4th, you're going to move your decimal place 4 times to the right. Our number on our calculator was 45578.1. We would have to move our decimal a total of 4 positions. And since our number was larger than 1, we would have a positive exponent there. So it's important to begin using scientific notation when you're doing calculations. At the bottom of page number 3, you're going to see your first calculation, which shows 0.08 grams, the mass of something, and then you're going to see a graduated cylinder that shows 35.0 milliliters. So what we have there is an example of a multiplication division problem, well, a division problem, that shows a mass with how many significant figures, and then a volume with how many significant figures. 0.08, 1 sig fig. 35.0, 3 sig figs.